developer and transaction infrastructure that includes a couple different components. The main one being the SDK. And this infrastructure helps you to build applications that deliver seamless and effortless experiences for your end users. So Biconomy is perhaps best known for this SDK that allows you to easily plug and stack a bunch of different APIs that provides benefits to your end users, including gasless transactions, batch transactions, one-click user journeys, social login modules, and much more. So we're very lucky to have Biconomy to be a sponsor of the Bear Necessities Hackathon. They have some really cool bounties, which I'm sure Rahat will tell you about. And there's also time for questions. So feel free to ask any questions that you like in the side chat. And with that, I'll hand it over to you, Rahat.
Thank you. Awesome. So I'll go ahead and share my screen and we can get started. Okay. Cool. So today I'm going to go over a couple of slides, give you a little bit of information to build up on what Kevin just said about Biconomy, and also we'll go through like a quick demo and of like something that you can build and do today on top of the Biconomy SDK and using the principles of account abstraction. Then we'll like review a little bit of code of like how that works, and I'll give you some resources as well, and like how you can like continue to look at some of the code and like build with the Biconomy SDK. And yeah, like Kevin mentioned, we are sponsoring the hackathon, so definitely check out the bounties. I will talk more about those towards the end of the presentation. But yeah, today we're going to be talking about how to start building with account abstraction today using the Biconomy SDK. Thank you for that intro. Just, I guess, quick recap, head of developer relations at Biconomy. I usually look like one of these two pictures on the internet. So if you ever find me, I'm one of these two things. You can, like after like going over anything in this, workshop, feel free to like reach out to me on Twitter is like usually where I'm reachable. Happy to give you more resources, happy to give you more information or anything like that, or if you want any like have any clarifying questions, happy to go over that as well. But wanted to kind of like focus on one thing before we go into like the rest of the presentation, and like that's the current user experience of Web3, and the current Web3 experience. Like in the chat, just say yes if you've ever like accidentally committed private keys or like API keys to GitHub without actually putting in a git ignore or something like that, or maybe you forgot. People in the chat, yeah. Anyone done that? Yep. Socrates, yep. I've done that myself. It's like not a pleasant experience, especially in like Web3, because like if you commit private keys and like that wallet has funds in it, like you're kind of wrecked. For anyone who's like has a bot like sniffing around for any of those keys, so you kind of like live in that fear, right? And there's like a lot of like really cool developer tools that help you mitigating that, but like the fact that those are necessary tells you that there is a user experience problem with like even among developers, even among like folks who are like considered very technical, to be able to like safeguard these private keys that you're going to be using with your dApps that you're testing or you're building, and like committing those and whatever. So and that goes beyond just like the technical side of things. It's not just like developers, like regular people, like a regular person coming in and trying to onboard into Web3, like the first thing they have to do is like create a wallet. And along with that wallet, they get like a seed phrase, they get private keys, they have to like figure out how to safeguard all these things and learn about the safety of this. And that leads to like a very complex user experience in Web3, because like first you're onboarding onto like a wallet, and then after you've onboarded onto that wallet, you need funds on that wallet, and only then can you go and like use a DApp, right? Because like you have to go through that full experience first before even like being able to use a DApp properly. And if you're building a DApp for like consumers and users, that's something you just kind of have to deal with, because like that's just how Web3 works right now, right? Um, you have to like help people through all these other friction points before they can even use your product, and that's not the best way of doing things, especially if you're trying to build something during the hackathon that you want to use for consumers, or you want to like bring users into. You want to make that user experience, that points of frictions, as little as possible. And then, ultimately we go into like these gas fees. Like we've been able to mitigate gas fees with like layer twos and like other alternative layer ones and things like that. But at the end of the day, gas fees still exist. Like they're still there in some form or another, even if they're small. Um, Someone still has to go through the process of like onboarding some native tokens on whatever network they're on, to be able to use a DApp, right? And that concept of like paying for every single transaction doesn't sit well with a lot of like non-Web3 native folks. So we have to like start thinking of different ways that we can, again, just mitigate as much of these friction points as possible so that you can have users on your DApp, so you can bring as many people into your DApp. Because if you're only building for Web3 native folks, sorry to tell you, you're not going to have a very large user base. So we do, if you want to have a large user base for your dApps, if you want to start, building dApps that have customers, that have users, you have to like appeal to, more types of people. So how can we just improve that Web3 user experience? In comes something called account abstraction. So account abstraction, as we kind of know it today, has been kind of like governed around what's called EIP 4337. EIP 4337 essentially gives you what's called an entry point contract that can be deployed on several different EVM chains, and governs a lot of the different types of transactions and types of user flows that we're going to be going over. But at the end of the day, the gist of what account abstraction is and like how to look at it is going to be that it's just the ability to add arbitrary logic to the process of validating a transaction, right? So you have a transaction, you have some information about it, you have the data, you have a contract maybe that it needs to go to, you have like a nonce associated to it, you have some gas fees. And then after that, it's just like adding more information on top of it. What other information can we add to it? Maybe there's something called a paymaster contract that you can have information about, which will allow you to sponsor the gas fees, or even allow the user to pay gas fees and like whatever token they want rather than just the native token. So this additional information around the transaction, it gets put into what's called a user operation. So user operation is kind of like sort of a new type of transaction. It's not really a transaction. The user operation just has information for what will eventually become a transaction. But you can look at user operations as sort of like the new a new data type that has information about the transaction that needs to take place, as well as additional information for adding that arbitrary logic to the specific transaction. And these user operations are all in what's called an alternative mempool, which can all be handled by the entry point contract. So to actually like create these user operations, that's done using what's called a smart account, or basically a wallet that is powered by a smart contract, a wallet that is powered by code instead of ECDSA, or so this allows for like additional types of authentication, additional types of logic to be placed on top of your code, as we've like mentioned here. So the thing to really like kind of ask yourself as you're starting to like wrap your head around account abstraction, as well as just like how to use it in your dApps, is like, how do you want to authenticate yourself? How do you want to authenticate a transaction? How do you want it to eventually execute? AA is probably going to help you kind of like give those additional requirements to the transaction. So just like a very quick overview of like how this works from a visual standpoint. The green box here is basically representative of a smart contract wallet. So this is just a wallet that is governed by code. It can be owned by a externally owned account which is like your regular kind of like wallet account that you may be used to. It can be owned by not even the that account. It can be owned by like what are called passkeys, like your hardware can generate passkeys that own that account as well. And another thing is you can like create social accounts that can essentially help you be the owner of that smart account. The thing to like differentiate between a smart account and like a regular EOA is that like a smart account doesn't necessarily have private keys. It is owned by something else. So it can be owned by an externally owned account, external account that has the private keys. It can be owned by a passkey situation, and that that specific thing that is helping you to create the smart account to own it is like what governs who has access to the smart account. So other than that, it still works like a regular wallet, right? You're sending transactions, except the transactions in this case are user ops in this alternative mempool with all of the information needed to actually execute a transaction. What happens is we need what's called a bundler service now to actually take a look at this user op mempool, to take a look at the different user ops and send them to the entry point contract that is deployed on each chain. So the bundler is just a service. It can be written in TypeScript. It can be written in Rust. There's different bundlers that exist out in the world, and several different protocols and companies are building out these bundlers so that you can use it. With our SDK, you do get like the full kind of like thing. You get the ability to create smart accounts. You get the ability to like have a bundler that can read the user ops, and we kind of abstract a lot of that away from you, so you don't have to worry about it. We're working on now modularizing it so that you can use like other bundler services and other different bits and pieces of our full kind of stack, if you don't want to like use the full thing. But today's example is going to be showing you that full flow. So eventually the bundler takes the user ops and will send them to the entry point contract, like I mentioned. And the entry point contract has a function called like handle ops that'll essentially just handle the user operations and eventually execute it. Before executing it, it may send it to what's called the paymaster contract. So that paymaster contract can help you do things like, sorry, I'm not sure why my screen keeps switching, but that paymaster contract can help you do things like sponsoring a transaction, so making that transaction now gasless, or doing things like allowing the user to pay in like an ERC20 token for gas. So like, let's say I wanted to just pay for my transaction just using USDC. I could do that with the help of a paymaster contract. We're actually going to be releasing a paymaster paymaster very soon that allows you to pay in different ERC20 tokens. Right now, our paymaster supports mainly the gasless side of things. But yeah, account abstraction can be pretty difficult to wrap your head around. It might take a couple bits of reading and resources. I do have a couple of Twitter threads that you can scan this QR code and take a look at, where it kind of like breaks down some of the stuff again that I spoke about. It'll take you through like, what are user ops, what are like the different parts of the ERC-4337 that powers all of this. So definitely recommend taking a look and checking this out when you have a chance. Just an additional resource for you to kind of like go in and learn more. So I went through some of that stuff, some of the different smart contracts and services that power it. You probably don't want to code all of those things yourself. Having some of that extracted away is probably a good idea, especially when you're like a DApp developer and you want to just like get started building with dApps. So today we're going to be learning specifically about the Biconomy SDK, how it can help you do a lot of these things. And we're going to start things off with a demo. I'm going to do the demo, then we'll dive into the code. So this demo, if you've been following me on Twitter, is one I've been sharing a little bit around. But essentially, this is a miniature version of Uniswap. In this example of Uniswap, you will only be able to swap USDC. That's all I've implemented. Let me actually just switch to a different browser, just because that browser I forgot actually has sensitive emails that I don't want to share. So I'm going to hit this connect to Web3 button. Once I hit the connect to Web3 button, I get one of the first really cool pieces of, I guess I like to call them like Lego pieces that we offer from the SDK, which is social login. This specific social login is powered by Web3 Auth under the hood, but using our SDK, what you can actually do is like generate an account, a smart account, either using your MetaMask, you can connect, using your EOA, or you can continue using like a Google Auth or even email login as well. So this goes back to what I was mentioning before, like the smart accounts themselves, they don't have private keys. They're owned by something. In this case, you can have it owned by like a MetaMask or any other wallet using Wallet Connect. You can have it owned by your email. You can have it owned by a social login account. So I'm going to go ahead and log in with my Google account. Cool. And you'll see here that a address was actually generated for me over here. And if I copy this address, I can do things like sending, funds to it. I've already got some funds, so I won't do that now. But this address here is a smart contract account. This is a address associated to a wallet that was deployed by our smart contract factory. So in the background, what had happened was like when I authorized with my Google account, Web3 Auth gives you an EOA associated to that Google account, and that EOA is the owner of the smart account. So I do have funds on this wallet, but if I did not, if I was just like a non-Web3 native user, first thing I did was I eliminated the need to actually onboard myself through a wallet. I have this like in-DApp wallet that I can use, right? Now I can do things like buying crypto, right? Doing some fiat onboarding just right within my DApp. This is another module of our SDK that allows you to do, fiat onboarding. I have this set to USD, but you can do several different types of currencies around the world. You can choose different networks that are available through them. These are the different networks that is available through this transact module. I already have some USDC in this account, like I mentioned, so I'm not going to go through with that full thing, but you can onboard yourself through credit card, through bank account, through things like Apple Pay, Google Pay, and everything. So very modernized, I guess. Cool. Like I mentioned in this specific example, I only converted things for USDC. So it's going to be USDC to ETH. This is currently on the Polygon network. I'm working on having this on other networks as well. But we'll just do like a swap for 1 USDC for the equivalent amount of ETH. Hit the swap button, and the swapping is now currently happening for me. So what's actually happening in the background is that for every time that I swap some USDC for ETH, I'm actually approving an amount to be I'm approving the exact amount that I want swapped every time. So I'm only approving 1 USDC for the swap, and then I actually execute the swap, right? So there's 2 transactions happening, but it was just like 1 click, right? That was just a 1-click experience, approving and swapping in one go. Now, the benefit of having like that approve and swap flow every single time you do the transaction for someone who's new to Web3, they might not. It might be easier for them to like just keep that approval happening for only the amount that they want, because without understanding, a lot of people can approve like tons and tons of amounts of tokens to be swapped for their for Uniswap or any other DEX, and without understanding if they were to like have their account hacked, if they were to have their account jeopardized in any way, someone could like maliciously come and do things where the approvals were already happening. The approvals were already going through, and that introduces some security risks. So this is a good way for non-Web3 natives to have a safety net for, only approving the amount that you need to swap and swapping that. So safety net plus the one-click transaction all in one go there. So you'll see that this transaction was a success. I successfully took 1 USDC and swapped it for the equivalent amount in wrapped Ether. Cool. And my smart account should update on that just in a bit. But this is sort of like a basic how you can implement account abstraction principles into an existing sort of like application today, right? This is an example of that. So this, you can actually play around with this right now if you wanted to. Try this out yourself. It is deployed on aaswap.vercel.app. Like I said, you don't need anything other than an email account to get started and some USDC, which you can get through that Transact, or you can send from your EOA wallet to that address. But yeah, there's also a link here for like the Biconomy docs if you ever want to go straight into the docs and start working on things. So that was the demo. Let's take a look at some of the code that actually empowers this. So actually, before I go into the code, let's look at the Biconomy dashboard, which is going to actually help you to get set up to implement a lot of these things in your DApp. So when you go to dashboard.biconomy.io, you would log in. You can log in using email, GitHub, etc. There's a few different options. And what you're going to do here is set up a paymaster. So these are some of the different paymasters that I have set up. I'm going to click new paymaster. You choose the network that you want to be on, and you name it, and then you register. Once registered, you're going to be taken to this page, and you're going to be prompted to set up your gas tank. So I set up my gas tank. You connect your wallet. These are different options for connecting. Once you connect your wallet, you then deposit some amount of funds onto the gas tank. So this is the example that I just showed you. I have a bunch of funds in here set up already. But once I set up my funds, now I need to actually authorize what contracts I want to be able to be authorized with the specific API key, right? So here I have authorized a few different things. I have a swap router. This is from Uniswap. This is the Uniswap v3 swap router that actually handles like the swapping between different assets. So this is what's helping me to actually implement the swap between USDC and WETH. I also authorized, I'm going to add like link into this later, but I authorized WETH and USDC as contracts as well. So if I hit the edit button, you'll see that I added the smart contract address, and based on that, the ABI was automatically populated. If it's not a actual like verified contract, you can copy and paste the ABI in here. And what will happen is that you'll see all the different write methods for the contract pop up, and you can authorize any of them to be sponsored. These will be the actual methods that you can turn into gasless transactions. In this case, I did like this exact input and output. These are like the actual swapping methods that get called. So those are what I actually authorized to be gasless. And then on the USDC side, the approve. Remember, I mentioned that we do like an approve and swap. So approve is one of the authorized transactions that I can use with the SDK. And then I also did a transfer. So, I haven't added this in yet, but I'm going to implement like the ability to transfer out funds into like any other wallet. So I'm going to make sure that's gasless as well. And like I mentioned in the future, this is to set up the gasless transactions. Like you're essentially paying for the gas for your user. no matter what chain you're on, that can eventually get expensive depending on how many users that you eventually do have. So our next paymaster is actually going to give you the option of letting your users pay in whatever ERC20, in like certain ERC20, not whatever ERC20, but like certain ERC20 tokens. So in our case with this, one of the new updates that we'll be making is like, rather than sponsoring the gas, they pay for the gas in USDC. So that's something that's coming out very soon. Well, hopefully you'll be able to play with that too. So now coming to the code, how do you actually implement this on a front end? So this specific code base is a Next.js code base on the front end. We can start with like the connection of the front end to our SDK. So the thing that you want to notice here is that really what we're doing is importing just a couple different packages into your front end. And after that, it's really just some amount of boilerplate code that goes into this. So the first thing I want you to take a look at here is this login functionality. So the login that I showed you before, just like I said, a few lines of boilerplate code. You're just initializing a new instance of our social login SDK. You're whitelisting specific URLs. So in this case, I have this put out on I have this deployed on production on aaswap.vercel.app. So I'm whitelisting this specific URL to have all of the redirections, which Web3 auth does under the hood for like logging in through social login, etc., and all those type of things. And then I'm just initializing things on whichever networks that I want, and making sure that this is like a mainnet transaction, or going to be on mainnet, because I deployed this on a mainnet, but you can switch this out to testnet if you're doing like just regular tests and building things out. The next part here is the actual setting up of the smart contract. So the smart account. So the wallet that is governed by the smart contract. Here, I'm just grabbing a Web3 provider. In this case, the Web3 provider is I'm using Ethers to grab a reference to the SDK ref that I have up here. So I'm basically taking the Web3 provider given to me from Web3 auth and passing it to the smart account. You can also do this directly, let's say from like Ethers, WagMe, or like any other type of front end tools that you like. It just needs some type of Web3 provider that has accounts associated to it, and you pass it to the smart account initialization to create a new smart contract address. So the thing with that new smart contract address, it's what's called a counterfactual address, meaning you know the address before that smart account is actually deployed. So you'll see here that I'm checking if the account is deployed or not. And if it is deployed, I actually call this method called deploy wallet using Paymaster. And what happens there is that it takes the address that was created for the account and deploys a smart account associated to it, so that you can actually start doing transactions with it. And when you do it this way, you sponsor that you sponsor the deployment of that specific smart account for the user. If you don't want to do it this way, when the first time that the user actually tries to do a transaction, it can also do a deployment. The gas fees associated to that deployment would just be added to their first transaction. So 2 ways of deploying the smart account: either do it for them or wait for their first transaction, in which case it'll be added to the fees on that transaction itself. And from there, I can get some basic user information. I can actually access their Google account information, etc., just like their email address and who they are, how they logged in, just like the basic stuff that the Google OAuth API exposes. Cool. So that is like your connection. The next thing to really look at would be the swap. So the swap component. So there's this function I have in here called handle swap. So the actual swap itself is handled this way. I have a pool address. This is like the pool address of like WETH to USDC. This is just an address on Uniswap that shows the liquidity between WETH and USDC and how the funds are like allocated there. The swap router address, which is the one I showed you on the dashboard that I authorized to do the actual swap. Just information about my tokens, the address of their accounts, the decimals, and their symbols. And the main thing here really is I get an instance of the swap router contract using Ethers, which just takes the address, the ABI, and a provider. The provider is coming from the smart account itself. And here, I'm actually getting my approval amount and getting the approval transaction ready. So to actually get started with creating a transaction that would be sent through the smart account, you would use this populate transaction method, and then the actual method that you want to call itself. In this case, it's approve. Approve takes the swap router address and the approval amount, right? So every single time I'm giving in a specific approval amount that can be approved for the transaction. So that's the approval transaction. I grab information about it, which is like which address this needs to go to, as well as the data associated to this transaction. Now, this is what's actually helping me construct the user operations in the background. You don't have to actually construct it yourself. You just give the object a couple pieces of data, and then in the background, our SDK is actually going to handle taking this information and turning it into a user operation. And then the second part is the second transaction, which is the actual swap. These are the parameters that Uniswap needs in order to make a swap between two different tokens. So one would be like, what is the token in? What is the token out? What is the fee, address, a certain deadline, the amount that's coming in, and a few other pieces there. We're not going to go too deep into like the DeFi Uniswap part of things, but you can take a look at the Uniswap documentation to see how a lot of these things work. The parameters here are really just for this demo. So I would not recommend copy and pasting these values. This is strictly for a demo. Definitely take a look at the Uniswap documentation for like how to construct these parameters a little bit better before implementing your own swaps in like mainnet or anything like that. And then I doing the same thing as here, where I got information about the approval transaction. I get information about the swap transaction. I send the data and the swap router address. And for actually sending the transactions themselves, I use this method called send transaction batch, which allows me to send multiple transactions in one go. So I just construct this array with 2 transactions. And once I'm ready to actually execute them, I just pump them into this object, and I can really put as many different transactions as I would like in here. So like if you're really into DeFi, I would definitely like look at like what are the different things you do in DeFi that you want to make a little bit easier, make one-click experiences out of. In this case, I did pretty simple one where I just did the approve and swap. But like if you want to really go into it, there's like providing liquidity, maybe swapping and then providing liquidity in one go, or like some of the different things that you might do in the DeFi space. Make that easier. Make it like one-click experiences for people to come in to be able to do. So those are like the main pieces of the SDK code there that I wanted to focus on for this. Like I said, a lot of this is available. A lot of this is really just available on our documentation. Copy paste the boilerplate code of like how you send the transactions, how you actually set up the connection to our wallet. I also have here an SDK starter kit. So this starter kit actually has several different examples in it. So the example I showed you was like pretty complex using Uniswap v3 router under the hood. This SDK starter kit actually has more simple pieces of information, like how to go in and create like your own NFT mint. It has a very basic starter where it's like just a counter smart contract that increments, and you do that like gaslessly. It also has like a Next.js social authentication starter. So if you were like really interested in just implementing the social authentication and building your own stuff from there, you can do that too. So just a few different like options for you to get started. That may be a little bit simpler than the demo that I showed today. But yeah, really excited for folks to get started to building. If you are excited to build, definitely tag us on Twitter at Biconomy. Let us know. I'm also Rahat Codes on Twitter. We have a couple of different bounties that are available for you during the hackathon. So we've got total prizes of $5,000. First place will get $3,000, and then 2 runner-ups will get $1,000 each. And a couple prompts that we have. So one thing we'd love to see is like you using the Biconomy SDK to build like different one-click experiences for folks. So I showed you like that one-click experience of going from the approve to swap in one go every single time. We would love to see like what other types of one-click experiences that you can build out. It can be in DeFi, it can be in other spaces. You don't have to like just do something in DeFi. There could be maybe NFT marketplaces and the other use cases that you want to see in there. Another one that another prompt that we have that we would love for folks to be able to build with is just like figure out how to onboard users who are not native to Web3 into your dApps, right? Like I mentioned before, if your dApp is strictly kind of focused on making sure that Web3 native folks can use it, you might not have as many users as you might like. So figure out how to open your app up to non-Web3 native users. You can use our social login features, gasless transactions, things like that to make it easier for non-Web3 native folks to come in and start building or like using your app in general. So would love to see like different use cases with those 2 prompts. Like I said, 5,000 in total, 3,000 to first place and 1,000 each to 2 runners up. But yeah, thank you. I think, Kevin just like put in the SDK starter guide in there as well. And yeah, I can grab a share link for this and send it to folks. See, anyone with the link can view. Copy that.
Thank you so much, Rahat. And we just have a question here. It's a little bit hidden, so I might be able to copy and paste it into the other chat here, just so you can see it there.
Cool.
Here we go. This is from Socrates.
Okay. Hi. If I understood correctly, then you logged in with your email. An EOA was created that owns a smart account. Yep. What is happening when I click a button on the website DApp to swap for example, does the front end button call the COA account that calls? So when you actually do the swap, the EOA only like I guess sort of like owns that account and what can help you. Like if you were to do this with like your MetaMask wallet being like the EOA, you would have to do like signatures. So like not like actual transactions, but just like signing the transactions every time you want to do something. In this case, what Web3 Auth is allowing us to do under the hood is like abstracting the signatures away. So there is some signatures that go through like your EOA to actually give permission, but we're abstracting that out for you so that you don't have to sign every single time. But the actual user apps and transactions are handled through the smart account and not your EOA. The EOA private key is held wherever your EOA private key is held. So in the case of like if you're using just a regular wallet, it would be held the same place where MetaMask holds it. for Web3 auth, it's held on their end. You're able to export that out anytime you need. So it doesn't change the way that the private key exactly is held. And for like the smart account itself, there is no private key. So it's simply owned by some externally owned thing. So on the Biconomy side, we don't have access to any of these smart accounts of the private keys of your EOAs or anything like that. Any plans to integrate Talisman and or Subwallet? We're definitely always looking at potential folks to collaborate with. I'm not too sure on these two at this moment, but definitely we're always looking to expand on that side of things.
One of the things I thought of when you were mentioning the DeFi examples was like zapping in for different protocols. So that could be really cool. Somebody could maybe build out a feature that does something like that, or recreates maybe a feature that's already out there.
Definitely.
And I loved your emphasis on building new products for Web 2 people, not just for Web 3 degens, right? Because we want to onboard new users here.
Definitely.
And so I think that's a huge focus.
Absolutely.
This is amazing, Rahat. And people saw the SDK starter guide here on GitHub, and we have the slides. I mean, this is everything. I mean, this is awesome. Yep. This is a really, really comprehensive workshop. And so thank you so much.
Yeah, definitely happy to do this. And thank you for having me on.
Oh, absolutely. And we have one more workshop tomorrow. That'll be StelSwap. That'll be at 12 p.m. EST. And then we also have a full range of office hours happening next week. So if you're working on your projects and if you have any sort of stumbling blocks, you don't need to wait until next week. You can always get help in the Moonbeam Discord. That's discord.gg/Moonbeam. If we can't answer your question, we're going to get you to the right person who can. Then if you want to talk about projects in more depth and detail, then that's kind of what the office hours are for. And so we want to welcome you all to those office hours starting next week. And thank you so much for joining us, Rahat. I can't thank you enough.
Cool. Thank you all. Have a good day.
Thanks.